This video is going to be on Chapter 9, Part 2, and it's going to focus on the pages in the notebook 54 and 55 for the notes. And those pages focus specifically on graphing a quadratic in factored form. And so what you're going to notice is that your function is going to look a little different in this case. It's going to look like two factors being multiplied together. So I'm going to do the notes on this page 54 and 55, and then I will also record the you try section, but I will not be recording the homework for this lesson. I'd like for you to try that on your own and then take a look at the answers posted on Canvas. Don't forget that whatever your teacher has for the exit ticket or Math Excel, whatever that assignment is, don't forget to do that after you take your notes. So this lesson focuses on graphing a quadratic equation in factored form. And here is the function here in factored form. So y is equal to a positive or negative a in the front, and then you have two factors. Now the m and the n are going to stand for whatever your factors are going to be. So like x minus 5 and x plus 2, something like that. Now there are 6 steps that I'm just going to read briefly before we start. It says to graph a quadratic in factored form, first you want to identify what your x-intercepts are. And what you would do is set each of those factors equal to 0 and solve for the x-intercepts. There is also another name for x-intercepts. Sometimes they are called solutions or roots or zeros. So if you see that word instead of x-intercepts, they mean the same thing. Then what you're going to do is plot those two x-intercepts on your graph, or maybe you have one of the x-intercepts. Then for number 3, you're going to find the x value of your vertex by using this formula. X is equal to those two numbers added in half divided by 2. Or just think, what is exactly in the middle? Because you have what's called an axis of symmetry that cuts your picture perfectly in half, your axis of symmetry should go in between wherever those two numbers are. Then number 4, plug that x value back into the original function and solve for the y value of your vertex. Then you're going to plot that vertex and then use that a to graph the rest of the points for your smooth curve of your parabola. So if you look at the notes, there are 3 questions that walk through graphing from factored form. And then on the next page, page 55, we'll have a couple graphs given. And from these graphs that are given, how do you get the factored form? So I'll show you those 2 methods. So for factored form, here are our first couple examples. So graphing when you're given the factors. So in this equation, you have y equals -1, and in parentheses, x plus 2 and x minus 4. If I set each of my factors equal to 0, I will get my 2 x-intercepts. So if I subtract 2, I'm going to get -2. And if I add 4 by solving for x, I get positive 4. So my 2 roots, or also known as solutions or zeros, my x-intercepts would be one at -2 and the other at 4. So I'm going to plot on my x-axis those 2 intercepts. Now you can make a little bit easy work of this, or you can use the formula. I just like to count in the middle. Your axis of symmetry, that x equals number equation, should be exactly in the middle. And that's what you're doing here, is by adding these together and dividing by 2, you're finding the average, which is in the middle of those. So in between -2 and 4, I'd get 2 divided by 2. I would have the number 1 be exactly equal to 1. Or if you want to think just count, like how far are these apart? 1, 2, 3, 4, 5, 6 units apart. So in the middle would be 3. So in the middle, I would draw that axis of symmetry. Now, if my axis of symmetry is at 1, that means my vertex has to be 1 comma something. So if I know my vertex is going to be on that line, that vertical line x equals 1, how do you find the y value? Well, you plug x equal to 1 into the equation. All right, so y equals -1 plus 2 and 1 minus 4. So this will be -3 times -3. And when you multiply these together, you get a value of 9. So now I'm going to plot my vertex, the point 1, 9. Here, I'm going to turn my light on just for a little bit more light. Now, as I'm looking at this picture, I do see that I have a negative, and I can kind of see how my shape is going to begin to form. This is going to be the maximum of my vertex, because from my vertex, I need to go down to touch those x-intercepts. So this is going to be a max. My axis of symmetry I already found was at 1, and it's going to open down. Now all I need to do is just get my picture. So if you remember from the previous lessons, with your A, you go over 1. Now in this case, because I had a negative 1, I'm going to go down 1, over 2, down 4, and over 3, down 9. So think like 1 squared was 1, 2 squared was 4, 3 squared is 9, and that's where those numbers are coming from. So over 1, down 1 in both directions, over 2, down 1, 2, 3, 4, and then over 1, 2, 3, down 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. I'll connect those with a smooth, curvy parabola. And there's my graph. I'll show you 2 more times the same process. In this case, I have 2 factors. I have a factor of x plus 4, so set that equal to 0. Subtract your 4, you get x is equal to negative 4. X minus 2, set that equal to 0, add 2 to both sides, you get a root of negative 4 and positive 2. So put those x-intercepts on your x-axis. Now what I'm going to do is use these 2 numbers and find my axis of symmetry, because it goes exactly in the middle. So again, if you want to count, you can just count and find the middle, or you can do the average formula that we had up here. So if I take negative 4 plus 2 and divide this in half, I would have negative 2 divided by 2, which is negative 1. So my axis of symmetry is at negative 1. Or what you could do is just count. How far apart are these? 1, 2, 3, 4, 5, 6 units apart. So 3 would be in the middle. So that's where my axis of symmetry is going to be, exactly in the middle of those 2 points. Now that I know that my vertex has to be on this axis of symmetry, I'm going to plug in x equals negative 1 into the function. So I have y is equal to a third, and then negative 1, my x, plug that in, plus 4, and then negative 1 minus 2. This is a third of, actually this is going to end up being positive 3, and this one is negative 3. This will be a third of negative 9, which is going to be negative 3. So my vertex will be, when I plug in negative 1, I get out negative 3. So down here. Now, as I'm looking at my picture, because my A is positive, my graph should open up, which means this is going to be a minimum. Now what I need to do is connect these with a point. So usually we go over 1 and you take your A times 1, and our A was a third. So I'm going to go over 1 up a tiny bit, a third, and then over 2, usually we would go up 4, but now I'm going to go up a third of 4. I don't even know how much that is. I'm going to skip that, because watch, if we go over 3, 4 thirds is 1 1/3, but if I take my A times 9, a third times 9 would be 3, and that's a much nicer point. So I'm just going to connect. So over 1, 2, 3, up 1, 2, 3, that's my x-intercept. I'm just going to connect those. So there's our graph. All right, now at the top of page 55, we're going to do one more example like this, and then we will kind of go in reverse. We'll do backwards. Given the graph, can you find the function? So on page 55, this is at the top, example number 3, we have the factor x plus 1 and a factor x plus 5. if I set each of those factors equal to 0, I will get here -1 and here -5. Sorry about my dog in the background. And then these two roots, -1 and -5, I'm going to plot here. Now, in the middle is going to be our axis of symmetry. Stella, it's okay. So in the middle of -1 and -5, if you just count, they're 1, 2, 3, 4 units apart. So 2 away would be right in the middle. Or again, you can just do the average, -1 plus -5, and then divide by 2. You would get -6 divided by 2, which would be an axis of symmetry at -3, which is exactly what I have here, a vertical line through -3. Now, my vertex needs to go on this line. So I'm going to take the number -3 and plug it into my function. So -3 plus 1 and -3 plus 5. This is going to be here -2, and this one is going to be +2, which means I'm going to get -4 for the y value of my vertex. The x we already found was -3. So at -3, -4, I'm going to put my vertex there. This is going to be a minimum, and it's going to reach up to that x-intercept on the right side and reach up on the left side. So this is a min vertex, and it's going to open up. Now our pattern, here I don't have a number out front, so I know my a is equal to 1, and if we go over 1, we're going to go up my a, which is 1 times 1, so up 1. And then over 2, up my a times 4. Well, if a is 1, that's just going to mean go up 4. So over 2, up 1, 2, 3, 4. That's my x-intercepts there. And then over 3, we're going to go up 9. So let's see. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this is going to match symmetrically on the other side. Over 3, up 9. Connect these with a smooth, curvy, U-shaped graph, and there's your parabola. Nice job. Now what I'm going to do for the notes is the opposite of what we just did. So given the graph, find the factors. And this is actually a little easier than I'm going to make it, but I want to show you exactly how you would find your two factors and then how to find your a. I think the a is kind of the hardest part because as you're looking here, you just want to make sure that it's following the same pattern that we normally have. And so I want to talk about that pattern. So as I'm looking at the vertex here, the vertex was a little bit hard to determine exactly where it is. I can tell it's in between 0 and 1, and it's down here a little bit past -6. So the vertex is kind of unknown. And so I want to talk about how you find your a when we don't exactly see this pattern here. Over 1, up 1, over 2, up 4, over 3, up 9. And so I want to talk about how you get your function. So just kind of what the function looks like from our page before. This function over here, I'm going to copy that down. We have y is equal to either a positive or negative a, and then you have your two factors. Well, I know what my two factors are going to be because I can clearly see what my two intercepts are. If my intercept has a -2 intercept and a +3, what would these factors need to be to show that? Well, if x is equal to -2, if I move the 2 back over here with my x by adding 2, my factor would be x plus 2 equal to 0. So this is going to be the factor that I need. And then if my solution is 3, if x is equal to 3, if I move the 3 back over with the side of x on the left side of the equal sign, I would need to subtract 3, which means my factor is going to be an x minus 3. So right now I know I have some a number, an x plus 2 and an x minus 3. But now how do I get the a? So here's kind of my easiest solution for you. Find any one point that you know on the graph for sure. And I would say avoid using your intercepts. I think it would still work with that, but I'm just going to use another point that I am 100% confident is on this parabola. So I noticed that these 2 points cross perfectly, the point 2, -4, or the point -1, -4, or even if you notice the point 0, -6 is a perfect point, or 1, -6 is a perfect point. So I'm going to use this point that I know so I can solve for A by plugging in a 0 for X, a -6 for Y. I'm going to solve for my A so I can be confident of what that A is supposed to be. So if I use the point 0, -6, I will finish finding the formula, which will be Y equals some number and then your 2 factors. So watch, if I plug in where you see your X, 0, and where you see Y, -6, we're gonna solve for the A that we need. So -6 is gonna equal the A we're trying to find, my X of 0 plus 2, my X of 0 minus 3, and now we're gonna find A to find our actual equation. So -6 is equal to A. Now 0 plus 2 is 2, 0 minus 3 is -3. That means A is being multiplied by -6. Well, -6 is equal to some number times -6. If I divide both sides by -6, I get 1 for my A. So here's my function. Y is equal to 1, I found my A, my factor of X plus 2, and my factor of X minus 3. Now you don't really need to write the 1. Writing that is kind of unnecessary, but that would be your function. Yay! Okay, we'll do it one more time. And then if you're still not getting it, please continue to watch and I'll show you with the U try section as well. So my x-intercept here is a -3. So for our function, we have y is equal to a, and x with a factor, and an x with another factor. Now these, it really doesn't matter what we're solving for, but I know that my factor is at a -3. That's my solution. If my factor's at 3, that means both of these numbers are going to be the same, because if I have one intercept, that means these factors had been identical. So if I know that my x is equal to -3, that's my solution, what would your factors have to be to make that work? Well, I'm going to add 3 over here with my x, so my factor would have been an x plus 3. So far I know I have x plus 3 and x plus 3. Notice how these are the same because I only had one factor. And I need 2 factors because that's the formula right here. And if I didn't have 2 factors, I wouldn't have a square, which means I wouldn't have had a parabola. So I have to have 2 factors. It just so happens that this graph has 1, 0, so those factors are the same. Now I'm going to solve for my A by using a point that I can clearly see is on this graph. There's a lot of points that you could pull out. I'll even mark a couple of them. Pick one of these points and we're gonna plug in our x and y. So use a point. Pick any one of these up points, it doesn't matter which one, and we're gonna solve for our A. My point is -2, -1 that I'm gonna use. I'm gonna plug this in for my x, and this for my y, and I'm going to find my A for my function. All right, so -1 is equal to my A that I'm looking for, an x of -2, and an x of -2 here. So I have -2 plus 3 is 1, and -2 plus 3 is 1. -1 is equal to A times 1. If I divide by my 1, I get an A of -1, and I need that for my function. So here is your function. Y is equal to -1, and then your factor x plus 3, and your factor x plus 3. That is the function for the picture that you see here. Awesome job today. that technically is the end of just the notes section on pages 54 and 55 for factored form. I will continue to go through the you try section, so you can feel free to pause it now and do the homework and check it to make sure you're understanding. Just don't forget to do your assignment, whatever that is for your teacher. But if you feel like you just want to see one more problem, feel free to continue on with me. The you try section is on pages 56 and 57, so I'll go through those next. So on the top of page 56, I'm going to go through these two factors, and what I'm going to do is make the graph. If I have a factor of x plus 2, that means my 0 would be -2, and if I have a factor of x minus 4, when I set these equal to 0, that means my other solution would be at +4. So here's +4 and -2, and now I'm going to find my axis of symmetry next. My axis of symmetry is going to go exactly in the middle. So if I take -2 plus 4 and divide it in half, the middle is going to be 1. So at +1, that's going to be my middle where my axis of symmetry is going to go. So I'm going to write here, axis of symmetry was at 1. And then my two solutions that I found here, or roots or zeros, are -2 and 4. Now I'm going to find where my vertex lands. My vertex, I'm going to find by plugging in the number 1 that I just found. My vertex has to go on that line. So in my function, I'm going to plug in where you see the x is the number 1. So I get a negative times 3 and -3. Negative times negative is going to cancel out, which means my y value of my vertex is going to be up at 9. So my vertex is at +1, +9. This is going to open down to reach those intercepts. So I'm going to put max here and open down. Now if my a is -1, I'm going to go over 1, down 1, over 2, down 4, and over 3, down 9. Over 1, down 1, over 2, down 4. And that will match symmetrically on both sides, and then I already have the third one down with my x-intercepts. Not too bad. Again, this graph is going to have a couple x-intercepts, and set those factors equal to 0 to find out what they would be. So 2 x-intercepts, one will be at +1, the other at 3. So these are a little bit closer together than the other ones that we've done, but that just means right in the middle, I don't even have to do the formula for this one. I know right in the middle is +2, because it has to go exactly in the middle based on symmetry. Now plug x equals 2 in. So y is equal to a 2 minus 1 and a 2 minus 3. So I have 1 times -1, which means -1 will be my vertex. When I plugged in 2, I got -1. So here's my vertex. And if you notice, it's already going over 1, up 1. So over 2, up 4. Over 2, up 4. Over 3, up 9. And over 3, up 9. And then go ahead and connect those points with your curve. This is a minimum on the graph, and our graph opens up. At the top of page 57, I have one more. So this is still the you try section. My a here is equal to -1/3, so I know that means my graph is going to open down. My factor x plus 1, set that equal to 0 to solve for my roots. And then the same for x minus 5. So -1 and +5. Right in the middle will be our axis of symmetry. So right in the middle would be at 2. And my vertex is going to need to land on that line somewhere. You know, where is it going to go? here, x equals 2. My two x-intercepts, I forgot to write those down. And I already said open down. If my graph opens down, we're going to have a high point, which is a max. All right, now let's find that vertex. If I plug in the number 2, I'm going to have 2 plus 1 and 2 minus 5. So 3 and 2 minus 5, negative 3. A third times 3, that's going to make negative 1, and negative 1 times negative 3 is going to be 3. So at 2, 3. So what I want to check for is my pattern. So from the vertex, because our A is a fraction, this is just kind of going to be slightly annoying, but this is how you would go. You would go over 1 and down, because it's negative, a negative A, we already said open down, a third times 1. So over 1 down a third. And then over 2 from the vertex down a third times 4, which is 4 thirds, or 1.3 repeating. So down over 2, down 1 and a tiny bit. And then over 3 down a third of 9, which would be a third of 9 or 3, which is nice because we already have those points labeled. And I'm just going to connect those with a smooth curve. If you want to keep going, the next one that comes out really nicely, I think, is over 6 down 36, because 6 squared, but a third of that would be down, gosh, what's a third of 36? 12. So if you want to keep going, over 1, 2, 3, 4, 5, 6, down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I guess I didn't have my arrows quite right, but you could continue on anyway. So there's my graph. All right, last two. You're hanging in there. You're doing a great job, hopefully staying safe and staying healthy. For our graphs to get our picture, so exactly opposite of what we did here, we need to fill out this formula. Our formula is y equals a, and then your x with your factors. So in this picture here, and this one here on page 57, I have two factors. If my x was equal to negative 1 and my x was equal to 4, my factors would be, if I move this back over and add 1, a factor of x plus 1. And if I move this back over with x, I need to subtract it, so a factor of x minus 4. So y equals a, my factor of x plus 1, and my factor of x minus 4. Now I talked a little bit about how you find that a, and this is how you have to find it. You have to use another point on your graph to plug in so we can find it. I noticed that there are a bunch of points that look really great that we could use that cross right through a point, you know? Any one of those points we can use to plug in to the x and the y to solve for our a. I'm just going to use this one here. I'm going to use the point 0, negative 4. And I'm going to plug 0 in for x, negative 4 in for y, and then I will find out the a that is supposed to be for my function. So I'm going to plug in negative 4 for my y, 0 for my x. I have negative 4 is equal to a, and then 0 plus 1 is 1. 0 minus 4 is negative 4. So a times negative 4. Well, if I have a times what makes negative 4, well, that's going to be 1. So here's my function. Y is equal to 1. And then my factors, x plus 1, x minus 4. Cool. Then I have one more picture over here. One more picture. I have two factors. A factor where my solution made 1 and my solution was 4. So my factor is going to be opposite sign. So a factor of x minus 1. And if I move this back over with the x, it's going to be x minus 4 to have a solution of positive 4. And now let's use any other point on the graph to find our A. So I'm going to use this point. Let's see. Ooh, that looks like a nice one there. Here's a couple others you could pick. Look for ones that cross right through that point. I'm going to use 0, 4. That will be probably pretty easy to plug in. So y value of 4 is equal to an A, 0 minus 1, and 0 minus 4. 0 minus 1 is negative 1. 0 minus 4 is negative 4. 4 is equal to A times, well, that's going to make 4. 4 times what makes 4? 1. So here's my function. Y is equal to 1, x with my factor minus 1, and x minus 4. Woohoo! Awesome. Hope you're having a great day.